What do a gold ring, table salt, and the air we breathe have in common? They're all made of matter. But not all matter is the same. Some substances are simple and pure, while others are combinations of different ingredients. The science that explains this is based on three foundational concepts: elements, compounds, and mixtures. Understanding them helps us make sense of everything around us, from the food we eat to the medicines we take. Let's start with elements. An element is the simplest form of a substance. It cannot be broken down into anything simpler by chemical methods. Each element is made up of only one kind of atom. There are over 100 known elements, and each one has its own unique properties. Think of gold. Whether it's in a coin or a ring, gold is always made up of only gold atoms. That's why it shines the same way and doesn't rust. It's chemically stable and pure. Another everyday example is oxygen. When we breathe in, we're taking in oxygen atoms, an essential element for life. Oxygen doesn't have a taste, color, or smell, yet it fuels every single cell in our bodies. Without this element, human life wouldn't exist. Similarly, iron, an element, is used to build everything from bridges to cookware due to its strength and magnetic properties. Next, we move to compounds. A compound is formed when two or more elements combine in a fixed ratio, and undergo a chemical reaction. The result is a substance with entirely new properties. A great example of this is water. It's made of 2 hydrogen atoms and 1 oxygen atom. Hydrogen and oxygen are gases, but when combined chemically, they create a liquid, water, that can quench thirst, put out fires, and grow forests. Another well-known compound is table salt or sodium chloride. Sodium, by itself, is a highly reactive metal. Chlorine is a poisonous gas. But together, they form a white crystalline solid that makes our food taste better. This transformation shows how powerful and interesting chemical combinations can be. Let's not forget carbon dioxide, a compound formed from 1 carbon atom and 2 oxygen atoms. It's essential for photosynthesis in plants and is also the gas we exhale. It plays a crucial role in climate science, plant growth, and even the fizz in carbonated drinks. Now let's talk about mixtures. Mixtures are combinations of 2 or more substances that are not chemically combined. Unlike compounds, the components in a mixture retain their individual properties and can often be separated easily. A perfect example is air. Air is a mixture of nitrogen, oxygen, carbon dioxide, water vapor, and other gases. Each component maintains its identity, and we can separate them using methods like distillation. Another familiar example is trail mix. It might have nuts, raisins, chocolate chips, and seeds, all mixed together but not chemically bonded. You can easily pick out the raisins if you want. Similarly, soil is a mixture of minerals, organic matter, air, and water. Its composition varies from place to place, which is why different crops grow better in different soils. Mixtures can be homogeneous or heterogeneous. Homogeneous mixtures are uniform throughout, like sugar dissolved in water. You can't see the individual sugar grains once they're dissolved. Heterogeneous mixtures are not uniform, like a salad, where you can clearly see and separate the different ingredients. Understanding these distinctions isn't just about passing a science test. It has real-life applications. In industries like pharmaceuticals, knowing the difference between compounds and mixtures ensures proper drug formulation. In food science, creating the right mixture of ingredients affects taste, texture, and shelf life. In environmental science, Distinguishing between pollutants as elements or compounds helps design better treatment solutions. Think about recycling. Separating materials like plastic, glass, and metal from mixed waste is a physical process based on the idea of mixtures. Understanding mixtures also helps us understand solutions, alloys, and suspensions, each with its own application in daily life, from toothpaste to stainless steel to muddy river water. Right pointing finger emoji. If you're finding this journey into the science of everyday things fascinating, don't forget to like this video and subscribe to the channel for more content that turns classroom concepts into real-world understanding. To go even deeper, consider this: every material around us is either an element, a compound, or a mixture. Your smartphone. The screen is made of compounds like silicon dioxide. The casing might be an alloy, a mixture of metals. Even the battery contains lithium, an element, combined with other substances to form a compound that stores energy. Science becomes powerful when we see it beyond textbooks. When you understand that a glass of lemonade is a mixture, that rusting iron is a chemical change forming a compound, and that helium balloons rise because helium is a light element, the world begins to look a lot more connected and logical. The next time you cook, clean, breathe, or travel, remember, you're interacting with elements, compounds, and mixtures constantly. This knowledge not only explains what things are made of, but also how they behave and why they matter. That's the real power of science, making the invisible visible and the complex simple.